Waiting to be live. Looks like we're live. Let's make an announcement. Copy the video URL, because I have a video URL. We're going to work more on Hibiku. It is, hopefully, for a book. Ping notifications. Ping everybody who's interested in being notified. Notify everybody who's interested in being notified. That is. I've got my water. I've got my mouse and keyboard, I guess. I don't think I need anything else. Hello! I should say hi after trying to drink water. Akish. However you are supposed to pronounce it, do let me know. Well, I'm glad. Happy to see you too. I don't have a very strong plan for where we're going to go this episode, this stream. I think we're just going to start the parser. I was thinking at some point maybe I write some of the book with you guys, but I feel like a lot of this writing is going to be very dry and me self-critiquing myself entirely too much. So maybe we look at the book portion, but I think... Okay, yeah, I think we're mostly just going to keep working on the reference implementation for Hibiku, and I'll worry about the book when I'm a bit more confident where the book is going. Then I'll stay off stream unless you guys really want to see it. My room is way too hot. We're going to take off my pants. This is why we don't have the camera on. All right. So, parser. I think we just about finished up the Lexer last time. There might be one or two more features to add, but let's see. If I do make Hibiku, we have some tokens. That's good. I had some to-dos to look at, so we'll see if any of them are worth to-doing. Creating an allocator. Oh, we are going to probably want that eventually. We don't technically need it right now, but we could do that. We could do a pool allocator instead of starting the parser. We want to do interning when we get the pool done. So these two are dependent. This is dependent on this. If anybody doesn't know what a pool allocator is, feel free to ask. Floats and hexadecimal need to be lexed. That's what we left out, was the fancy integers, or fancy numbers, non-integer numbers. And diagnostics. That's probably the next thing we do is diagnostics, because we're going to start having a lot more parse errors in the parser. There's a handful of things to error about in the Lexer, but most of this is going to be parse errors. So we probably want to do the parser booba-da-doop-doop after we do diagnostics. So let's take a look at where we want to put them. Probably in HBK API. Let's make a new struct. Yeah, pool allocators are a thing. Let me just put a to-do in here. Remind myself that this is what we were doing. Diagnostics. So a pool allocator is an allocator that you can use. How do I explain this? So let's make a new file here. Normally, when you allocate some memory, you get back a single pointer from wherever the hell the allocator can find it, right? So if I had like, I want to allocate a kilobyte, right? This is going to be some random pointer from wherever the next place in memory, probably virtual memory, is that the OS wants to give you, or something. I don't, words. That is not how I wanted that to format. Anyway, so if you know how regular allocators work, you get this and you can call free to free the memory. Because every single call to malloc, you are responsible for calling free for, which is really annoying, especially in C, when you don't have fancy things like destructors or defer or anything like that. So you get one pointer back. It is 100% your responsibility, and it just comes from a random place. A pool allocator, on the other hand, is something that you kind of manage on your own. We're going to do exactly what we did here, but we're going to make a really big one, and we're going to call it our pool. Or instead of doing 1 kilobyte, maybe we want to do 1,000 kilobytes. And then our pool allocator function, we can just say void star pool alloc. We need one more thing, but we'll get to it in a second. We want to allocate some number of, right, some number of bytes. This is our own custom allocator function. What we're going to do is we want to return some part of the pool. We don't know what part of the pool yet because we also need to keep track of how much we've allocated. By default, we've allocated 0. We're pretending we've allocated nothing because we've pre-allocated a block of our own custom memory we can manage. So what we're going to do is say allocated plus equals count. And we're going to say void star result is pool. Then we can return the result, and now every time we call this, we'll get something that is progressively farther and farther into this pool, right? So I can say void star foo is pool alloc 10 bytes from this. And this address, let's assume that the assumed pool is at address 0, just for easy math. Foo is 0. It's at address 0. It's at the start of the pool. If I go to bar and do the same thing, allocate 10 more bytes, bar is at address 10. And we can keep doing this, and it's 20, 30, 40. They're just going to keep going. And at the very end, when we're done with all of the memory, we can just call free on the pool, and all of this memory gets freed. So all we have to do is keep track of a single pointer representing our pool, and every other allocation we make is completely free, basically. We never have to track it. It's not going to hit the operating system anymore. It's already aware of the memory we've requested. It's doing whatever behind the scenes bookwork it needs to do to give us that memory whenever we access it, right? It's not perfectly for free, but we've pre-allocated a bunch of memory, and we never have to allocate memory again. And we want that. We really want that. Technically, in a short-running application, you really don't have to worry about freeing memory, but it's very good practice to just have a handle on your memory. And we are going to follow that good practice and keep a handle on our memory. Does this make sense? Did I explain that kind of correctly enough for you to understand it? It might make more sense when I actually implement it, because I think that's the next thing we're going to do. We'll probably even do it so it makes you able to not allocate free memory 10. I don't understand the question necessarily, so maybe I didn't explain it very well. I mean, you can you're allocating all the memory ahead of time and freeing it all at once. So there's nothing to track. It keeps everything local as well. So you've got everything allocated space after space after space. It's not being like fragmented and shit. That's basically it, yeah. So we are probably going to put that in the API file as well. I'll just call it a pool, make it nice and simple. And it's going to be a little fancier than just one block of memory. We're actually going to do many blocks of memory. And I actually think I'm going to make this a little opaque. That's the word I'm thinking of. So let's come in here, and we want HBK pool. HBK pool create. We want to be able to create one. We want to be able to destroy one. This will be our free function, basically. When you destroy a pool, you free all the memory associated with the pool. We then need to be able to allocate memory. So void star HBK pool alloc. And we want to take in a size t of size, count, the number of bytes we want to allocate. And technically, we could also ask for an alignment if we wanted to be fancy. We almost never need it. We can just auto align to 16 bytes or something internally. We don't need an alignment. So I think for simplicity, we'll just do that. I guess we'd align to 8 bytes, whatever. We'll align automatically inside. And we don't ever have to do a free because destroying the pool frees everything within it. We're just going to blindly allocate into the pool and destroy when we're done. For pool create, usually I give it like a size T of block size, but I don't think I care. I might care. This is the thing that we're doing slightly different than my example here. In this pool, we've allocated exactly one 10K by 10K block that we can allocate. What I want to do instead is allow you to have multiple blocks that it continues to grow like a dynamic array would. A line of max align T is what you want probably. Okay, yeah, we can do that internally then. Usually 16. Cool, I was right. So I guess we'll pass in a block size, but I usually just arbitrarily pass in like a kilobyte and call it good. So maybe we also just define that internally and don't give it to the user because it really doesn't matter all that much. So if I go into HBK API, see we have two things to do. We want to copy those over to implement, and we want to grab struct, because I'm lazy, struct HBK pool. Now this is going to need a block. Type def struct HBK pool block is a block. The block is going to be doing most of the heavy lifting. We're just going to have all of the memory for the block. Hold on. My work computer just made a noise, so I've got to see what that means. Oh, that meeting's at 11 a.m. That's not a meeting. That's not a meeting. Yeah, my work computer's making meeting notification sounds, but there's no meetings. I am off work. Please don't do that. That's scary. Okay. We need a block of memory. We need a size T for the memory capacity, we'll call it. The block size, basically. We can just call it size. I'll be a little bit more specific with the name here. The total capacity. And then a size T allocated total allocated. I don't know. Words are hard. Well, we only need those three variables, basically. And then in the pool here, we have access to HBK API, which should give us vectors. So we're just going to implement a pool in terms of a vector, which is an HBK vector of type HBK pool block for all of the blocks that this pool is responsible for. So that also keeps track of the capacity and the count of each block. So when we create a pool, we need to do a couple things. We need HBK pool Diala one size of pool to give us a nice fancy 0 initialized pointer. Well, memory. And that's what we'll return at the end. We'll throw in insert pool not equal to null because I like checking and do the standard sorting by more RAM. So then we need to add a new block to the pool, which I'm probably going to put. Okay, good. For some reason, I thought my mic was going to be. Is the volume of my mic good, by the way? I was watching back part of my stream and it sounded a touch quiet, but it might have just been a bad. So let me know how mic sounds. Right. I think we're just going to say void. Sounds good. Yeah, as in. Okay, cool. HBK pool add block. We need to take in HBK pool, and it's just going to append a new block and do nothing else. So that's like the first thing we do here. Append block pool, add block, whatever. So we need now an HBK pool block. I'm probably No, that's fine. I usually leave these as values, and then it just gets slightly more verbose. But I think it's fine. I think we'll just keep it as values, not allocate too much. So a block is going to equal something. And to keep ourselves a little sane, we're going to make some constants here. Define HBK pool block size, capacity, which is going to equal 1024 by 1024. We're going to do a K of a K as like a huge block, maybe. Maybe we only do like 64K. That's probably better. 64K at a time. Depends on how big our stuff's going to be. This is why I like to leave it configurable. I bumped my mic. Oops. But we'll change that as necessary. So we can say memory capacity is our pool capacity. I'm leaving this variable here so that we can make it configurable. We don't have to do this in the future. That's why it's there. Our total allocated is 0. So then all I have to do now is allocate the memory. So this is going to be, for sanity, calloc this, and size of car, really, but just 1. That many 1 gives us a 0 initialized memory. Dot memory equals memory. And vector push pool blocks our new block. Now we have created a pool that has a block in it, a single block. So for as long as we have not filled up 6K or 64K of memory, it will be sufficient. But whenever it runs out, we need to be able to add a new block. So before we get to adding new blocks and allocating memory, let's also remember to free our pool. I'm going to check if pool is null, just return, we don't care. That'll be our check there. We don't have to assert. If they pass us a null pointer, there's nothing to destroy, it's probably okay. So one thing we have to do is free the pool. The other thing we have to do is free all of our blocks. Ooh. So just for I equals 0, I is less than vector count of pool blocks. I plus plus. We need to free pool blocks of I memory. And then just for shits and giggles, we probably also want to like 0 this pointer. I was going to say 0 the whole thing, but the easiest thing to do is just set it to null. And then before we free the pool, we can also free the blocks. Or, you know, vector free. Do I have vector free? Free the vector, 0 init the vector, which I think vector free does. Yeah, resets it to null. Free the vector, free the pointer to pool. We have now destroyed a pool. I did that kind of fast. I hope it makes sense. Now to allocate. Allocating is the important part, so that's where I'll slow down. To allocate memory, we need to do a couple of things. We need to find the current block we want to allocate into. We need to align our pointer when we get there. We need to find the current block, see if it has enough memory. If it does, we can allocate into it. If it does not, we need to make a new block, and that becomes the next block we want to allocate into. First thing we can do is assert that count is less equal to our capacity here, because we're never going to be able to allocate something bigger than that. Tempted to allocate something way too big. Please don't. As HBK block, that's our block there. We're going to get a pointer to it. Even though we're not allocating it on the stack, we still have access to a pointer to it. Through reference to this needs to take in a pool. HBK pool. Pool. Nobody told me I forgot a pool in my allocator. Trying to keep you guys on your toes, and you didn't. You failed. You failed the test. Anyway, reference to pool blocks. Intelligence really doesn't like that. Why not? Hello? Oh, I didn't. Block equals pool blocks. There we go. Sub. I don't have like a vector back, so we're just going to keep doing vector count of pool blocks on this one. I should probably do a vector back to make this not suck. I can even throw a to-do in here. No, me being janky, I forgot to do the name plus an equals, so it had absolutely no idea what I was doing. So now we have a block. That block definitely should exist. So HBK assert block knows with the fucking block knows with the null. What the? Then if block memory capacity minus block total allocated, if our count is greater than that, and this is the amount of space left in the block, right? The total capacity minus what we have currently allocated is the amount of space left. And we should probably, before we even do this check, align it to the nearest 16, or however we want to calculate that, and then we'll do the check. So if count exceeds this, then we're going to do this. We're going to append a new block. We're going to grab that new block and double check it again. Then here we can void pointer result. The memory that we've allocated is block memory plus block. I don't think we can do math on it, so we'll give it a second. Total allocated. This is going to be void or car star, so we can do math on it. Then I think that's really all we have to do. Now we just increase total allocated plus equals count and return result, question mark. I think that's the allocator. I think that's an entire implementation of a block, a pool allocator with blocks. We'll test it out in a second. So align, so you said a line of, which should be a thing, max align t, which is just a type here, cool. So many windows. Oh my god. So size t max align is this. Now align of, is that it? Max align t is undefined. You may have to include standard align. Include std align. Aha. It really doesn't like that word. It's fine, it found it. Std align. That doesn't get me max align though. What did max align come from? Standard def? I figure I should be including standard def already, but okay, well, it looks like it's caught up. Yeah, 16 UL, that's fine. So then to do max align, a line of, so we want to do, I know how to do it, I just don't know how to do it quickly and efficiently. Like the way that I can quickly think of to do it is, okay, maybe not on one line. If I'm trying to do it on one line, I want to get the remainder before and to divide it by whatever, multiply it by, get the remainder at the thing. So the quick way to do that, right, so what I'm saying is if I do count over max align times max align, then I get it rounded, floored to max align. Align minus, that's the one I'm thinking of. I can never remember that. He's got it in his head. So it's count plus equals then max, I won't even call it max align, we'll just call it align. Align minus value mod align on align. And it's not value, it's count. Right, so this should align it to the nearest align bytes. Ah. So if it's already aligned, then align will be 16, this mod align will be 0, so 16 mod 16 is 0. That's what we're looking at, basically. If this is 8, we want to add 8 bytes. So align minus this mod align, count is 8, mod align is 8. Or, you know, if it were like 16 plus 8, 24. 24 mod align is 8. 16 minus 8 is 8. Mod align is 8. That gets us the additional 8 to round up to the nearest, right? You're aligning up to the nearest multiple of this value is what we're doing. Hopefully that makes sense. I'm not going to comment it because I know what it means, and I'll explain it more in the paper, the book, the whatever, when I get to that point. So now we've got alignment. We should have a pool allocator. What we're going to do... Yeah, I would hope the compiler knows how to do that. That's such a well-defined thing. HBK API. So Hibiku has HBK state. HBK state is in hibiku.c. This includes HBK API, which gives us pool allocators. So HBK pool. Oh, that one? Yeah, that's ugly, though. That's ugly as fuck. So we're going to call this string pool for interning strings. That's our step 1. We're going to intern strings here. So when we create state interned string pool is pool create. And that's it. Oh, I should be a good C programmer and call this void. Because that's what C programmers do. Don't need this anymore. Okay, so back in this one. So we've created the pool, and then I don't think I have a state destroy yet. Oh yeah, if I'm using C23, I don't have to, that's right. What? Fix this one. Okay, then fix this one. Beautiful. I forgot that was a thing that they did. Okay, so we don't need API right now. Don't need H right now. Back to Hibiku C. So we have a state create, but we never did a state destroy. So we should do that to be good and happy about our memory. HBK state destroy. Speaking of C23, yes, speak of it. Destroy the pool, then free state, and yeah, VS Code does not know that yet. A lot of these things don't work. In the first stream, we had bool was recognized as a keyword, but true and false weren't. So I still had to include standard bool anyway. So for my sanity, we're going to keep including things. So we'll destroy the pool. We also need to vector free state source files and interned strings. And we can destroy the pool and free the state. So now we've done memory management on our state. In our intern here, interning strings into the pool, we've already done a lookup. The lookup doesn't do anything right now because we're not interning it. But what interning is going to do is for every string that is identical to another string, it becomes the same string. So everywhere that we use the string foo in the program, they're all going to point to the same string data eventually, which is less useful when you have source text already allocated, but more useful when you're not doing that, which we will, like, if we're generating things or fucking like actual string literals maybe. I don't know. It's good to have intern strings so we can use a string view and not worry about hanging on to dangling references to strings. Because we could, at any point, just free the source text, and we'd rather be able to do that and not be beholden to having all the source text in memory. Which we might do. I don't think the Laia compiler is freeing source text until the very end of the whatever. Maybe we experiment with that here. Once you're done lexing a file, it frees the source. So to do local actually internal pool, then we have to reopen it. Yeah, I think we're doing it in the lexer right now as well. We have intern string here for character literals and string literals. We haven't done it for, like I thought I did. We didn't do it for identifiers here. So we should intern this. It's a string view. So intern string. If I do this, it interns an actual string, which is a vector. If I want to intern a string view, I probably have to implement that separate. I really should factor this part out. So then I'm going to have to give it a length terminated C string basically to do this, and it'll return true or something if it found it, and then I can do the actual allocation and interning also separately. Because I can intern a C string, I can intern a string, but I can't intern a string view. So let's get rid of this real quick. While we're doing string interning work, let's go ahead and say, I guess we return a bool because it's going to return a string view, and I don't really have a nullable string view. So bool hbk state lookup intern string hbk state. We want const car and size. I'm using 64 everywhere. Len. And that's going to be, I'm going to call it length and fine. Okay, so then we want to grab this. And this needs to also take a string view thing, string view out string SV or something, right? Why did I do that? It's this hbk assert out SV not with a null, not parameter required, not parameter required. So string that. So then state whatever. So then here, which we want to say out SV equals this, return true. If we hit the end, return false. So then here, we can say string view result 0, initialize it just in case, but it shouldn't matter. If it does return true, hbk state lookup interned whatever state string length ref results return results like that. Otherwise, we're probably still going to return. So maybe I just say fuck it, invert it, do the thing, result equals, and then return result at the end. But I don't know. So there, new data here, find the result, return the result. That's slightly better. Then we can do the same thing here. Put this in here. Tab, find results, grab the result from here, and result equals that. So now we've interned a C string. Final thing to do is string view. Let's call it SV. So SV data, SV count. Then we want to calloc SV count plus 1, and it's now the calloc is going to be replaced with the pool allocator, but just refactoring for now into SV dot data MSV count, and this can probably still be folded down, so we'll do that in a second. MSV count. So even better, I could probably just turn this lookup into the string view thing, right? Because then I can just say in state intern string data. Then I don't need the string view. Then if we hit here, see, this is what refactoring is. You don't do it right the first time or the second time. Eventually you figure out what the hell is actually right. So I think this is correct, like this. So result then just needs to be returned again. I don't need the temporary data length. So instead of calloc, it is going to be pool allocate. And the allocate is going to be the state pool, and we want to allocate length +1. Copy the data in from the string of the total length. The pool allocator will 0 our memory for us, so it's already null terminated. We return it. So then this becomes return intern string data of state string length, and I think that's it. Then this becomes SV data, SV count, and this also becomes string length. So now we can intern 3 different kinds of strings with our intern string data. And I believe that about does it. So then we don't need .sv. Yeah. If that builds, I think we're good. So then back in the Lexer, we can now intern string view, which I have not declared yet, but we need the Lexer state. Intern string is here. HBK string view. I don't think I changed anything about this whole text. That gives us that. So in our Lexer, we intern what we got from the location for this string value. And we should... This doesn't really need to be interned, if I'm honest. I might just do what I did for token kind to string, where I have just this map of characters. Problem, if we ever support Unicode characters, it's not going to be in that map. So I'll still be allocating really short strings anyway. So it might not matter. I mean, it doesn't matter short term. I can always change it whenever the hell I want. It doesn't matter. The question is, do I care if it matters right now? It's not going to happen that often, and in the correct path, it will definitely not be an issue. So we'll just intern string view again of L state location. Cool. So token string value dot intern string, intern string, intern string, and then it uninterns the string there. I mean, it doesn't unintern it, it just doesn't reference the string anymore. Okay, so in the Lexer, we are interning absolutely everything. So we can, should we desire, remove the entire source file from memory. If we do, then printing diagnostics needs to be able to reload the file back into memory. So we'd have to be able to do that, which is technically not hard. It's just technically not something we're doing right now. So source text here. If we request the source text, we don't know when we're done with the source text necessarily. So For the time being, we're not going to free source text until we're done with the program, but I'll add it to the to-do to think about freeing source text after Lex until it's needed for diagnostics. Of course, right? Because that's a thing. So we've done a pool allocator, we've done string interning. We'll have to test that works, which we should just be able to do, at least kind of, by running it again. It still prints hello world, so it did intern the string properly. It still prints print. So it's allocated somewhere. There's no errors. It rebuilt. This is, I mean, we can rm Hibiku. Run it again. There it is. So the allocator works so far. We probably need to stress test it by allocating more than 64K, which we can just kind of do for fun. If I come over here, I don't have access to the allocator from here. So on create, when we create a string pool here, let's just for int I equals, yeah, I mean, really all I have to do is allocate alloc from the pool, state string pool, the max, which is 64 times 1024, and this will be in block 2 by the time we allocate the rest of the stuff. So yeah, we're still getting good data. It looks like it's working. I think we're fine. We'll know if it fails eventually. We'll write better tests, but I think we have a pool allocator. So then we said we're not freeing source text just yet. I think we're ready for diagnostics, and we can worry about floats and stuff later. They're not difficult, but I just don't want to do it right now. Diagnostics. To implement diagnostics, I think, so HBK location is currently in HBK API, which is actually an internal thing, not an external thing. Despite it being called API, I really probably should rename it. Only Hibiku.h is the public API for being consumed as a library. Do I think I want to provide library users raw diagnostic information? Maybe. We're kind of just assuming they don't care, but they probably do. And if they do, then the location information also needs to be public. So it probably needs to be in hibiku.h as well. So I think location and diagnostic both need to get hoisted up into hibiku.h, because that makes sense. So then HBK API, somewhere we need to implement location create, which is just for convenience to not, it's just for convenience, I guess. This can still be implemented in API.c because I don't have a second hibiku.c, except I do have a second hibiku.c, don't I? So the one implementation of create, yeah, there it is. Can just come down here. Probably after all of the string interning. String interning is only in hibiku.c because it needs access to the state. So that's it. So just at the bottom here, let's do diagnostics. A diagnostic maybe should be opaque to the user. We're going to have a lot of data in there probably. So I think for now, we're going to make the diagnostic opaque, and we'll figure out what's going to be in it, and maybe we can make it not opaque and not have it. So a diagnostic is a message, which is probably going to be an interned string, because we're going to render it off to a string, basically. So it is a string view message, the rendered message. Then we want the location of the diagnostic, location. Then we need a severity of the diagnostic, which can be part of the public API here. That's fine. Type def enum kind. I guess I didn't explain what diagnostics are. If anybody doesn't know what a diagnostic is, it's basically your error messages or your info or your warning or whatever. Any diagnostic information that the user should know about. The UI, the AP, the user interface of your compiler, the compiler talking back to the programmer, diagnostic. So we're going to say HBK diag. We're going to do all the bells and whistles. So we're going to start with verbose, debug, info, warning, error, and fatal. We're going to do 6 levels of diagnostics because that's just what I always do. So then a diagnostic in here. That is not what I wanted to copy. That's fine. We'll have a diagnostic kind, a message, and a location. It really needs more than this to be a really good diagnostic, but I've never done more complicated diagnostics. So, hey Raid, what kind of diagnostic additions should I do here? Should I just keep like an array of related diagnostics? Question mark. If I wanted to say, hey, here's an error and here's the 3 things related to that error, but not require them to be separate diagnostics entirely. Like if I wanted to build a renderer like, who posted it recently? Melody. Was it in development? Was it in show off? I think it was in show off. No, I think it was in dev. It was in dev. That was way too long. Development. Way the hell up here somewhere. Where's the pretty renderer? Oh, we were talking to this dev guy for forever, so it's before that. It's before me talking about my web pages. From search. From Melody. And not search. Not from me. Not Discord search doesn't work. From. There's no from. Search options. Yeah, in this channel, I can do in. From. How do you... I swear from used to be a thing. Anyway, no, I didn't want to go all the way back down. I wanted to find a thing. If I wanted to do pretty diagnostic rendering, how do I do it? Where is the picture? Look at all this history. I swear it was like yesterday. There's no way it's this far back. Right? It might be streamer mode, yeah. I just wanted to see the pretty diagnostic printer. I forget where the hell he put it. One new message. It was almost there. Yeah, so if I wanted to do this, where we have the main error message, but there's messages associated with multiple different locations, right? This is in bin test. This reports this message. This is a pretty renderer. Yeah, I got it. Thanks. How to brain? Because I could say this is the main message, and then all of these child messages are just associated with it and are rendered differently, of course. So like my first assumption is I just do a vector diagnostic related diagnostics, right? And then the renderer can do whatever the hell it wants with this information. because I will still want a message and location, but I don't really need the kind. It's going to inherit the kind from the diagnostic, right? So like, I mean, it's fine. It's a bit extra information. This one, no, this one, it's fine. Discord is what I was looking at. Yeah, I mean, that's fine. It's not that much extra memory. I mean, it's probably like an extra 8 bytes because of padding, but you know, it's fine. I really want to put some effort into the renderer for this. I want to encourage people to build good diagnostics and renderers and actually report the correct kinds of errors and do error recovery. It's very important for compilers, and nobody teaches it very well. I've got to figure out how to make it look really fancy and sexy and approachable. I could just create a related diagnostic or something that just has the message and location again. But again, that just sounds like too much work. So I think that's our diagnostic. So given that that's our diagnostic, let's grab this and build something. So HBK diagnostic kind is going to be get kind from an HBK diagnostic. We want message, which is a string view. Oh, except HBK string view is internal, because we, of course, made it internal. Because I was like, yeah, const char is more than enough. Get message diagnostic. I should really probably make string not... Because the header for string is just these two things. We probably just want string. But string relies on vector, that's right. I mean, it only relies on vector in the implementation. This could just be a car pointer. Being able to return a string view at least is probably worth doing. I don't need to return a string as much. Yeah, if I just return, if I move one, I may as well move both. Indecision. I really should return a string view and provide facilities for using strings, because that makes sense. But also I don't want to complicate the API. So for now, we're going to leave it. I'll put it in the to-do list so I don't have to think about it for now. With string. That. That's a question for another day. Get message will return a constant char. After get message, we have location, HBK location, diagnostic get location. That's a location. Then let's int 64t. Do I have standard int included? I do. Get related count. Then get related index. We'll return a diagnostic and it'll take an index. Get index. And then for each related, we can get any of the 3 fields on it. So that's good. Then we need to be able to construct diagnostics because it's opaque. Why does it keep insisting that it's an incomplete type? Leave me alone. So then we want to say diagnostic create from a diagnostic kind kind from a HBK string well const var message. We probably want to also take in a length, honestly, HBK location. But no, that's good. Diagnostic create with a message. Because most times we're going to want a message, and it's going to be a constant string. If it's not a constant string, I want to make the location actually be second, and I'm going to mirror that here and here. Message will be third, because we also want to support create like v format or something. Format, and format, we'll take this, and just for completeness, format v will take va list. Yeah, I can intern the message too, and that'll happen in create probably. If I intern it at all, I'm not probably going to return it or intern it beforehand. I'll rely on whichever of these three becomes, or like, you know, the highest level will do the interning. Is it just VA list? VA list V, which means I need standard arg, and I have to hope that the compiler versions play well. Standard arg is part of my public API now, which kind of sucks, but it's whatever. So then all of this is how we're going to implement, yeah, VA list. All of this is how we're going to implement diagnostics. This is before we even get to rendering diagnostics. We just need to be able to keep the diagnostic info. Oh, what we forgot is void HBK diagnostic add diagnostic add related. And this one needs pointer to diag and HBK diagnostic. So diagnostic doesn't own any memory. So if we're going to intern the string, we have to also pass in the state, which probably makes sense. And then it can intern and the state will own all the memory. So HBK diagnostic related. So then for all four of these, we need HBK state first. First parameter is state. There we go. And this needs to go back up to the header file. Well, because I changed it, it doesn't exist anymore. Here. No, that's not here. I lied. Hibiku.h. Right there. There, and there. Yeah, I know it's wrong. It's fine. You figured it out. So for create, this will probably be our primary one that we want to do the interning for. So HBK string view message view is intern string v intern string just C string, this one. Intern C string state message. Which I think makes sense because both of our formatters are going to, I believe, automatically append null if we're using sprintf. So this is fine. Intern C string is our message view. They'll handle freeing the thing as well if it needs to be freed. So then all I have to do is return HBK diagnostic dot kind yeah, I have kind. Not kind is kind. Not happy. Dot location is location. Message is message. You. And diagnostic exists right there. So it should know that kind exists. We're in the same file, right? It should be. Yeah, right here. Okay, it's happy now. Well, that's all we have to do to create a diagnostic. Eventually, we can register with the state if an error has occurred, so it can like stop processing things. But for right now, this does everything we want currently. Then we want to implement format in terms of v format. And we want to implement related as just vector add, vector push rather, state related, not state, diag, related diagnostics, related, like that. And we just HBK assert. Yeah, we don't need the state for related, right? Again, if we're the primary diagnostic is the only thing that really tells if we've had an error, because related shouldn't actually have one. We'll probably want an API for creating partial diagnostics rather than requiring the kind and stuff. We want the state for interning anyway, so I guess kind being just 0 by default is fine for that. Diagonal, you put the null. Push into related. Then. So let's do format here first. Why is this mad? Why? Oh, because I removed the state. That's why. My brain. Okay, so here we want to what? VSN printf once and say int count is VSN printf. We want to pass in null, max len of 0, constcar restrict of format is format, VA list is V. We want to say VA list V copy, VA copy from into V copy V. Then we could even just use V copy here. And then VA end V copy here. And VSN printf, that's all we need for this. So I kind of want to bypass this intern and do our own intern. So since we're in this file, we can just intern string data, because we're going to have all the string data that we want. Message data, message length, like this. We could say int64t message length, int64t VSN printf. So then our message data is pool allocate. Oh, but if we're interning the string, that's right, it won't matter. It's going to do the same thing anyway. Okay, so let's just allocate the message data by saying, yeah, we should just calloc and then free, probably. Calloc, message length, 1, message length rather. I don't think message length includes the +1 for the null terminating character. We can look up VSN printf, I guess. It's always hard to find exactly what it is, because some of this might be fine. Return the number of characters that would have been written if n had been sufficiently large, not counting the null character. Yeah. Okay. So then message data is whatever +1. Mem copy into message data. No, not mem copy. Just run VSN printf again. Oh, I forgot I have man pages now. That's so good. Man pages for the men. We want to print into message data the message length +1. I think it has to include the null slot ? Format V, and we can VA end ? No, we're not VA ending because we never VA started. We passed it in. That's right. So then we have message data. Then we can just return this version diagnostic create state, kind, location, message data. We have message length, but I don't really need it for anything other than passing the message data in. Then it's going to recalculate message length. So I could turn it into a string view to prevent having to recalculate the length. Kind of an optimization. Diagnostic create format. No, but I don't have a string view. That's right. So yeah, if I interned string view, if I went back to what I just did and said intern string data or intern string view, would be fine. So then message view does the thing. So then after we get the message view, we free message data. We're done with the message data. We're using the interned string now. And that's good. So then we just implement VA list VA start format, V format, right? VA end V, what then we say HBK diagnostic result is format V, state, kind, location, format V, return result. I believe that is correct. VA start, whatever format, the next thing after end K. Cool. I think we have diagnostic storage. We don't have diagnostic rendering yet, but we can do a really shitty diagnostic rendering. Absolutely no problem at all. One thing I want to add to the public API before we get to the getters is probably shorthand for these. Nah, because we still want access to like format and whatnot. So I think we'll just longhand this and hope for the best. This is relatively short to type. What I was going to do is like HBK error returns to you a diagnostic error, but then I have to have 3 variants for error, which I don't want to bother with, especially if I'm going to write about this shit. So that's fine. Okay, add related. So then we just need to go do the getters down here. We'll just steal my funny, where's the diag? Return diag kind and do this as the implementation for everything. Return location. Return message data, which should be null terminated. Return related diagnostics vector count. And then return related subindex. Cool. I guess these asserts should probably be better assert messages because they're in the public API, not the internal, but that's also an easy fix if I need to. Like I could just say invalid state pointer. Invalid diag pointer. Invalid diagnostic pointer. Something like that, right? Okay, I think that's diagnostics. If I just come over here after state and say HBK diagnostic s diag is diagnostic create format, and I say state, I don't have a location, but I can create a location, diag error, then it really doesn't want to give me IntelliSense for this. Location create, which needs to have a source ID, so I should grab the source first. So we want source ID, we'll just do 0, 1, and then a message that's just going to say test mod D rather, and then passing 10. And is Viz going to be happy with that? Incomplete type is not allowed. Oh, because I didn't provide the definition. So that has to be in here. which is fine, but then I don't need any of these getters. So back to hibiku.c. Hit button. All of these, and grab the struct diagnostic into public. Paste this back in here. And then I don't have vector though. So I do still need the API for getting the diagnostics related stuff. Yeah, not having a vector and string in the public API might start causing some issues. Let me go back in here, undo this just far enough to get those functions back. Move this again. We'll keep both of these in the API just for symmetry. Like that. Even though you can still just index into related diagnostics, so we probably don't need that right now. Leave it in the implementation, but we can keep it out of the API until we want it. Not commit to having it. Okay, so location, diagnostic. That's location and diagnostic. Okay, so back into the entry point here. If I just fprintf and do a quick render of this, we want to, I'll just do a that. That'll be the error. This, we don't have to render that out. We need the file information, which will be s colon, we'll do mod ld plus mod d. That gives me the offset. I'll do the length as ld. It's not going to be pretty, it's just going to need to work. Mod d for the error kind, mod s for the rendered message, new line because it won't have it. So let's make this pretty and say hbk state get source name from test diag location source id, then test diag location offset, then length, then just regular old test diag kind, then test diag message. I didn't like that, that's fine. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Cool. This needs the state. And that should be, we should get an error message, technically, in the output if this builds. It does not build. Oh, it very doesn't build. HBK diagnostic is because I didn't put kind at the end. That might fix half the errors right there. Diagnostic kind. That fixed some of the errors. Unknown type name string view message. Ooh. Well, I can make it a const char. It doesn't have to be a string view. Even if we intern it, I could just back in here, message view.data. So we've made sure it's interned. That's good for us. And then message view data again. Again, those are all null terminated. This just really means I should probably pull string view into HPK diagnostic pointer, unknown name, related diagnostics, because we need to type def it first, because it's recursive. Then, okay, examples, hello, Hibiku01, 4 should be error, test 10. Okay, so it is working otherwise. And this just is further encouraging me to grab string.h and vector and move them into the public API. So if I grab vector first, this is really all I need to define a vector, but I need everything to define its API. So maybe we just remove vector.h. We can leave its implementation in vector.c. But if I grab vector's source header, whatever, put it there for vector, and string and string view right below it, then I can get rid of string.h and vector.h. Cool. Now everything that includes Hibiku has our string and string view. I still don't mind this, maybe, but string view, source name and text should both be probably string view. We'll take a file path in, probably, and then these are all fine. So this one might change unless I give a nice function to construct string views. So then hibiku.c needs to not use .data anymore in this needs to say string view, then statement about text is a string. Oh, we need a string as view function, probably. That can be part of the API we add. Somewhere in here, we said message, which should not be data. This should not be data. Then, yeah, so let's create a quick string function called hbk string view, hbk string as view, hbk string. And I can just implement that right above state create. Oh, references for state create. What have I done? Way at the top here. State create string as view, requiring hbk string view. Data is string. And int 64 length is vector count string length count length. I probably should just call it count. Okay, then the errors are moving. There they are. String as view of this. String as view of this. What am I missing now? HBK vector doesn't exist, nor does HBK string. So that's API and vector C and API H. Okay, so HBK API can no longer include either of those. And that's fine there. Okay, so then vector.c here cannot include that. It should just include API, which includes vector. Then are we back to where we started with a warning? So that's 109 Hibiku C. Name is const car. String is view. Doesn't. Oh, yeah, that's not very type safe. Uh-oh. So we need a C string as view then as well. C string as view is going to say int64 count is int64p sterlen. Const car pointer string. That might cause some bugs. Woo. C string is view, const car pointer. So then, string as view, this name is constant, which it probably should not be. So if I come in here, source file should probably have an HBK string or string view to the name. If we intern it, which we could, then it's HBK string view. So when I come into wherever we create a source file, we need source file dot name dot data. So we could stir and compare source file name count. The name is not the file path anymore. It's cstring as view of the file path. And then we already have it as a view. We just do that. The source text is allocated memory we want to deallocate in the future, so it's going to need to be a view still, or constructed in line rather. Okay, what about now? How does that look? Segmentation fault core dumped. Well, that's a start. I have debug information, so I could try running it through the debugger real quick. I think I have a launch configuration. I do. But that's very helpful, yes. Source ID 0, because this source ID is 0. The location, offset, and length should be the same. I think the string view. Yeah, that's just how C work, though. That's valid data. The message is test 10. It is rendered off. It might be a string. Yeah, it's a string view. That's why. Okay. So I need to provide HBK string expand as a macro in hibiku.h. And we'll put it right after string here. String expand versus, so this is SV expand, because string doesn't need expansion, it's already a car array. So we're going to just call this SV expand. Here, that's define SV expand. Yeah, I don't know. SV expand of SV should be int of SV count, comma, SV data. Okay, what about that? Segmentation fault, cool, don't. Why though? Oh, because now it needs to be dot star s, which should probably also be a macro. Segmentation fault, core dumped. Diag.message data count expands to message.count message.data. Probably recommend annotating your diag format functions with format. I probably should, yes. But also printf. Printf current problem. Lots of parens, that's all that matters. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It compiles, those fields exist. I might not be. That might be it. Let's go, we're running make right now, so let's go just add those to the make file. So GDB, we want W format, W return is 1, right? W pedantic, W all, fuck it. W, there was like a no unused, no, was it no unused that I don't want reporting? Or like W error to get it all to be errors. Yeah. I'll just do it for return now, but I could just do W. Okay. So if we run make again, so I have to turn it on and then enable it. Unrecognized command W. Oh. So this is GCC. Does GCC do W return too? So I know Clang is W return. I'm using GCC in my make file and Clang in my knob file. So I should definitely add these to knob as well, but return type. Yeah. Make file. W return type, but it really should just be error is return type. Okay. Format S expects argument to carpet got string view again. Oh, this one. Yep, that would do it. This first one, source name, should now also be expanded. Yep. Then, too many arguments to format, because it now needs to be .s again. Now it works. Okay. We did it. Yay. Lo hicimos. We did it. Okay, so that's here. Let's also do that in knob. Knob needs W format. W extra. So if I did W error all, does that just turn on all warnings as errors? I probably want to do it on a per thing basis, but pedantic, I just want to know if that's right. Then all for shits and giggles. No unused. An error. Return type. And then I can double test with knob. Oh. Hibiku. Ah, that's right, yeah. Okay, so then this one said unused parameter argc, Clang. We just said no unused. Did I spell it wrong? Maybe because I enabled W all? Probably don't need all, so I'll just take all out of both of them. We've specifically done what we want to do, so that's still, like, we've had this unused parameter. That's what it is. It's separate. God damn it. If I'd read my error messages, my diagnostics, unused parameter. Okay, there we go. And this gives us the address sanitizer as well. Which feels like it's not working because I don't think we're freeing anything yet. We haven't done state destroy. So I don't know that the address sanitizer is actually running. Oh, okay. Turn on WL as well. Make file. C. Okay. Yeah, where's my address? There's my address sanitizer. The make file is not doing the address sanitizer because it's running GCC. But knob is doing sanitize all, and there it is. So we missed 2 frees from malloc, from ensure capacity, from read tokens. Okay, we're not freeing the tokens array. That's to be expected. If I come into add source from file, we just kind of print all the tokens and then don't do anything. So we just need to free the tokens. Oh, it does? I haven't done it for GCC. Vector free. To get rid of that one, I assume it's the same syntax then, and I just need to grab fsanitize equals address. For consistency, I put it right after standard. Could not find asan. So yeah, I don't think that's supposed to happen. we'll figure that out later. Okay, so freeing the tokens leaves us with only one thing, which is read file as string. Read file as string. We never free all the source files, do we? So when we destroy, before we free this, for int 64t on equals 0 on is less than vector count state source files I plus plus state of source files sub I has a x which just needs to be freed, vector free that. So Clang is working just fine. Yeah, I probably don't have it installed globally for GCC. So Clang is working because I built it from scratch. And I built compiler RT and stuff. Okay. So I probably should have committed like halfway back. Git S, we have done a lot. And before I even commit, have we done something I can to-do off? Yes, it should. Diagnostics have been half implemented. We haven't done anything here. We need diagnostic rendering. Okay, so rework public API. Before we did diagnostics, we did pool allocators. Add pools and diagnostic. Just get that out of here before I make any more things. Can always do git add p to split it up. Yeah, I just don't do it that often, and also we did work in I've never really done it. So for now, it's fine. I'm not hoping to have the most accurate Git history. I should get in the habit of it, but yeah, bad about that. We're gonna worry about rendering the diagnostics fancy like later. So maybe I split this up into like fancy diagnostic rendering and regular diagnostic rendering, because we can go do diagnostic rendering right now. That's not difficult. The hardest part is just getting line information from, which I'm probably just not going to do for a little while. We'll worry about doing that later, because we're only going to be dealing with really short source files. So just, yeah, for now we'll do line information later. Let's do void question mark, because we could just say print. I want to like render a diagnostic in a way that I can use it in multiple places, but really if we're rendering the diagnostic to text, it should probably just go straight to a stream. Maybe I could put it into a string and free the string. Render to string is probably not useful, right? Let's do HBK diagnostic render to string. So we need an HBK state, the state in which it matters. HBK diagnostic, we'll do that next. Diagnostic, and then a HBK string pointer out string. Just string. That'll render to the string. The state is eventually going to need the ability to know about we'll use colors. We can turn on or off color information. So then down here is where we want to do diagnostic rendering. We can just say, grab an assert for two things, that state is not null and string is not null. State pointer and string pointer. So then we want to get source ID equals state get, oh, we already have source ID, so diag location source ID. Then HBK source file. That's that one? Yeah, source file. It should just be called source probably, but yeah, if I source ID, different namespaces, it's fine. HBK source ID, duh. So then HBK source text, probably. I don't know, just source. Because it's not a file anymore. Perfect. So then this should just be called sources. Then HBK source. Source is state get source. Well, I don't have just get source, so we don't care. We're gonna say HBK string view source name is state source ID, and string view for text is get source text. Is that not the same thing? Get source text as view. So I don't need this one anymore. That should already just have been the thing. Yeah, because this was implemented internally, that's why. So get as view also needs to just be renamed and then deleted, because now it's the same thing. Okay. So then we have the name, we have the text. We're not going to use the text just yet. I just wanted to make sure I had access to it. So in order to render to a string, I need to be able to append to a string. We may want to go do a second format operation here. So we have create format v, which is going to render messages. I might just want to go ahead and implement format to string, but I guess it doesn't really matter. I'll implement that eventually. Probably easiest if we implement HBK string. That. I guess it really will be because okay, we're gonna go implement string append format. That's just going to have to be the thing that we do. So void HBK string append format. HBK string pointer string car format dot dot dot. Which might want to be implemented in terms of format v, a list. And append format covers most of our append use cases. We can add more specialized ones to bypass it later. But for right now, we're just going to copy our implementation of formatting into these so that we can render things directly to strings. So this needs to do the ye old va list v start v format HBK string append format v string format v va end v, and then we can implement this in terms of vsn printf like we did down here, right? We can grab all of our data here. So then there's our copy, va copy, v copy, va list is v. I didn't include the v in here, did I? Not technically necessary. So then we have our message data. But really, we don't need to allocate anything. We need to say vector ensure capacity maybe, but we want to say set capacity to vector get vector count string plus message length. I'm going to include one. Oh, no, we don't need to. I guess we should keep it implicitly null terminated at all times, just in case. So set capacity, then copy into string plus the vector count for a total of the message length plus one format v. right? Then the string already owns the memory. And since the string already owns the memory, we can then call that good. So then our diagnostic printer, all the way down here, can say string append format, string. Then we want mod.start_s. That's our name, and we're going to do it with this text to indicate to us that it is byte offsets. What is it like? Is it comma? I'm going to do comma. Fuck it. I'll go look up what other compilers do if they do that at all. A lot of them don't. Render is going to want a new line at the end. That's that mod.start_s again for the message. And then the error string is going to go at the, not the error string, but you know, the, is it an error? I already forget. Did we put that at the end? File warning. Yes. Okay. So we want mod s to do the color, and then color reset flags. So I need a macro probably for doing color. We want our ANSI color codes, which I am more than happy to get from Laye include ANSI, and just put all of these into our public API. Way the hell up here. Bonk. Love bonking things. Bonking is good. So const car what was I going to say? Diag kind color is going to be empty by default if state use color, which we're going to have to find a way to implement turning on and off again eventually, but for now, whatever. If state use color switch diag, actually, let's just always switch on diag kind, because we also want to get the name. Color and diag kind next. Then default HBK unreachable probably would be very nice to have. We don't have an HBK unreachable yet. I closed the hibiku.h file. We probably don't have HBK unreachable because I don't have assert in the public API, so it'll be in here. Define HBK unreachable as HBK assert false unreachable. Like that. Simple enough. Then hibiku.c. You probably want to do that in terms of like an actual compiler trap. I forget what those are. Case HBK diag verbose. We have two things to do, so we'll put it in a nice fancy block. We want to say diag kind color equals ANSI. For verbose, I don't know that I care all that much. It probably wants to be like blue, cyan. Cyan's probably good. Diag kind text is warning. And then we can render off. Not warning. Verbose. 1, 2, 3, 4, 5 for debug. Yellow doesn't exist. Yellow does exist, but orange probably doesn't exist, so that's fine. Info, did I call it info? I called it info. This is debug. Info can just be green, white, blue, cyan, green for now. Warning. This is where I probably wanted to be like yellow, but purple is fine. Purple is magenta. Diag error is our good old friend red. And then fatal is our good old friend red 2. Because I don't know what else to put it. So fatal, error, warning, info, or like note. We could call it note, I guess. Doesn't really matter. This is all if it exists. And what I think I want to do is something I did in Laia to kind of emulate what I've seen other people do. We'll use color is state use color. And then I can probably not, like I don't need them in the public API. I don't know why I did this one. They'll be in the internal API, HBK API here, because then I can also define call of C as use color C or empty. And really what I want to do with this is like stir HBK. Do I still have HBK stir? I do. HBK stir of C. And that's not exactly what I did. It doesn't need to be HBK stir either. Hold on. Let me go figure out what the hell I did in Laia. Because what I did in Laia was nice. I'm trying to remember. Okay, hold on. Code Laia. It wasn't ANSI. It was just like... Yeah, I can't do that in C. So I emulated what you did in your compiler in C with a shitty macro. And that's what I'm trying to remember now. This. That's what I did. So it does concatenate with ANSI color and X. And that just allows me to like override some of these colors with new names, and it'll still reconcatenate the thing. So what I did there is I'd be like, define a color for a keyword to be red. So it would expand this into the actual keyword, or like the token red, and concatenate the ANSI color, so I'd get ANSI color red. So that's what I did in Laia. So we'll do color and color cat. That'll be fun to explain in the book. Oops. So then here, instead of saying this, we're going to say color this. So then format, so we want to do SV expand of the name, so that's source name. Then we want to do, I'm just going to say long because Windows. So if it's Windows, really I should call it LLD and say long diag location offset and then count. Didn't call it count, I called it length. So this should probably just be a call. That makes more sense to me. After length, we have kind color, is that what I called it? And then kind text. And then color reset. And then, oh, hello. SV expand of the message, diag message, which should be a thing. So that gets us a rudimentary diagnostic printer that doesn't do column and line number yet, and it doesn't render the source text yet. But now I can say, instead of doing this, I can say HBK string what's a prid? HBK string render target, and then render to string in the state the test diag render target. Then I can fprintf rendered error mod s new line. I think I included the new line actually, so this is fine. If I didn't, I should have. render target, and then vector 3 render target, and that should theoretically do the same thing. That's not what I wanted to do. Oh, it was way back there somewhere. Oh, Stack Overflow. That's bad. HBK string pointer. Oh. Okay, so that was in here, then string here needs to not do that. So this yeah, that. Where else am I using string? We need string to not equal to null, but then we also need the actual contents of string to not equal to null. Where else are we using string? Is that it? I think that's it. So then if I do this, the pen format still needs to do the correct thing. A pen format needs to string vector count string. God, I think all that makes sense. String as view is fine. Passing that in is fine. Again, still a seg v. Passing argument to parameter string here. Incompatible pointer to string car. End format string. Yes. Oh, because it does still. Oh, because I removed it in one too many places. This one still needs to be a pointer to a string. There we go. And then use color is off by default. I think I'm going to steal one more thing from Maya because I forget how the hell I did it. And that is include LCA plat as this. And this is going to go in somewhere. It doesn't need to really go in this could probably just go in main, honestly. So if I take this into here and say put it after main, honestly, and say this and bool standard error is a TTY, and then I don't need double void here or here. Then I don't really need anything else other than to enable color. So if I come into here, you need to be able to say destroy, add file. Let's just right here say void hbk state set like diagnostic color enable, set enable color or something. I don't know what I want to call that yet. That use color, set enable color, toggle color. Oh, in it. Okay, yeah, I was still confused. We'll use color. I don't know what it's for, honestly. I stole this from some probably LCC, maybe probably LCC, where we wanted to know if it was a teletype. Is it a TTY? Yes. That's where we get this. For color information. We'll probably get it for back traces eventually. But I know we get file info out of it, so. Enable color, state, use color, use color. So then we can say state enable color. state is a TTY for standard error. And if it is, we enable color, right? So then I can do this, not that, this, and we get, well, hold on. Use of undeclared identifier file no. What am I missing? Probably didn't include one additional standard bool, standard IO. That might be it. Just no standard IO is right there. Exec info unit standard. Where is file no supposed to be? That's a screenshot button. File no. That's not where file no is. What do you mean? What? Yeah, IO provides as a TTY, and UniSTD provides it as well. So then, what about file no? Isn't that in standard IO or unistandard rather? And why is it not happy about me trying to navigate to it? Standard IO is right there. Let's go ahead and throw these back at the top as well so they look normal. Yeah, file no should be there. Standard C library includes standard IO file no. Oh, you have to do the POSIX C source thing. That's right. I had already forgot that. So in, we'll do knob first. I need to include another define. Knob command append command d this and probably something else. Hold on. I had in laye we had one more thing question mark. These two. I'll just steal these two. Bonk like that. Then in make, do the same thing. This and this. That's why I had those there. I didn't remember that. There we go. So now we have error information with colors. Beautiful. So that was all for diagnostic rendering, I believe. So we can check off in to do regular diagnostic rendering. No fancy diagnostic rendering. Still doesn't have column or line information, still doesn't print the source. But that's fine, it exists. So we did diagnostic rendering. So git add simple diagnostic rendering, including support for colors. There we go, there we go. Do-do-do-do-do. Okay, we have been going for like 2 hours, and I haven't even gotten to the point where we're doing a parser yet. But we knocked a few things out. Do I want to keep going? I think bare minimum, we should start using the diagnostics and see if they work before I call it. So let's go into Lex. We have some to-dos. So the easiest one is this invalid character. So we can say, ooh, that's a thing. We do need to store them somewhere. See, that's good. Let me put this back. We just need to store them in the state. So what I probably want to do is add a new flag here called related or something and put it all the way at the very top so that it's not accidentally used. And store everything into the state, and then we can only print things that aren't related diagnostics, right? Oh, this can be a vector again. HBK vector related diagnostics. Okay, so then, oh, but if we're copying diagnostics because they're values, then we'll have no way of knowing what a diagnostic is. So maybe we should start reporting diagnostics as pointers? Diagnostics should probably be pointers, yes. Diagnostic pointer. Let's see what that looks like. Diagnostic pointer. Diagnostic pointer. Diagnostic pointer. Diagnostic pointer. Eventually, diagnostic pointer. If we go into Hibiku, start here. No, here. We want to diagnostic create. Should return a diagnostic. So then we need to say diagnostic result is, we probably want just like a general allocator pool for these kinds of things in the here. I don't know, stuff pool, generic pool, crud pool, misc pool, pool, misc pool. So then when we destroy the state, we also destroy the misc pool. Then when we're doing diagnostics, we're going to pool alloc state misc pool size of results, then return result, and I could also say result equals this literal here. Boom, return the results. Then pointer. So then the same thing here. Kind location message view, I think, is the same. Return results. Return results. There we go. Then to add a related to here, diagnostic related diagnostic. This should be diagnostic arrow, related diagnostics, which I don't have to do anymore actually, because now we have the vector API, so both of those get to go. Then diagnostic get related at index, we don't need any more. Render to string diagnostic pointer, so then everywhere that we see diagnostic without a diagnostic dot should be diagnostic arrow. Then here, this is diagnostic, and I'm using C23, so I can just call it auto. Right? Unknown address. Yeah, we fucked something up. Deadly signal. What did we not do correctly? An exception has occurred. Segmentation fault. I didn't create it, did I? I didn't create the pool. State create the misc pool. Okay, so now we're back to where we were. What I wanted to do is when we say diagnostic create here, we want to do something, right? It needs to be added to a list of diagnostics potentially. So here we have intern strings. This should be diagnostics. I think. Then creating a diagnostic, we should vector push state diagnostics results in this case and in this case. And then when we add related here, we want to say related kind is diag related. And that's all I wanted to do. So then if we try to render a diagnostic that's related to another diagnostic, it's going to hit this unreachable case, which is fine because it shouldn't ever happen. We only want to render diagnostics not like that. So. What I could do then, just to prove out that related diagnostics works, is iterate through them, but for now I don't think I will. This is a theme that a member of the Discord made. I don't think he's online right now. Where is Zed? Zed. This guy. Yeah, I don't have his name enabled. He's made the syntax highlighting for another programming language I'm working on called Laye, and he's working on this theme. I think he just called it 16 colors. Let me see if I can find a link for you. It's either show off or resources, maybe? He posted it somewhere. It's probably in show off. Finally added colors to my theme. Didn't link to it here. 16 colors right there. Visit. Copy link. I will paste it into resources here. Maybe? No, I don't need to paste it. Can I paste? I can put links. Thanks. Okay, so diagnostics. If you aren't already, join the Discord. Shameless plugs. It's in the description. Go talk to people. They're cool. Diagnostics are now pointers. So we have this stuff. We can render them to a string, which the state will eventually take over. When we have like state render diagnostics, it'll go through all of them or something. So we were going into the Lexer to add diagnostics. We can just be like discard diagnostic create, and we can probably create format here. And for now, since we're not doing anything Unicode-y, we can just say into else state of diag error at location. I should have a location, which is just going to be token location. Token location. Invalid character mod C in source text. And then that will just be whatever the current token whatever the thing is called. I think it was just current token, this thing. Current card, not current token. So send in the current token. And put that there, and then advance. So that is one. The next one, report that a character literal requires exactly one character. Don't mind if I do. Error at token location. That should still cover everything. We've increased, yeah. So we can say character literals must contain exactly one character. Okay, what does a character mean? Unfinished literal. And that'll be is carlet character string. Then no, we have one or two more all the way up here for nesting this thing. I think that's it. So unfinished block comment. That location needs to be start location, and eventually we'll track something different. Okay, so in my to-do app, we have unclosed block comments, unrecognized characters, this should have been non-1 length, and unfinished string literal. I think that covers those. So make sure nothing's broken, not git push. Knob Hibiku. Leak detected, because I need to now free all of the array in my free state destroy. So we're freeing in turn strings. We need to free diagnostics. Go. So we're still printing this diagnostic. Let's go generate a bad boy diagnostic in the examples file. So it shouldn't know about that should be an invalid character. We're not reporting the diagnostics though. So let's go report a diagnostic by saying HBK state print diagnostics to file, standard error. Render diagnostics to file, we can probably call it. So we go into hibiku.h. We have state, do all these things. Let's say void hbk state, state, file. I don't think we're including standard IO. So for the purposes of the API, we must include standard IO. Then we want to implement this. Put it here. This is where we want to say HBK string render target is an empty vector for int 64ti equals 0, I is less than vector count. State diagnostics I plus plus if it's auto diag equals diagnostics sub I if diag kind, Viz doesn't like auto either, is equal to diag related, continue, skip it, diag render to string, state diag render target, then I don't think I have to do anything else there. It's going to have new line, it's going to be null terminated. So f print f file mod s render target, and then vector 3 render target, like that. I think it's as simple as that. So then this is going to render those to that, and then this is going to say knob invalid character at in source text. Woo! So that's good. Hello Hibiku now needs to have like a unfinished block comment. Unfinished block comment. It didn't render invalid at though. Did I not I++? Did I do something incorrectly or I++? Render to string. Might it have overwritten instead of appended? Let's try something. Let's HBK string test. Append format test foo and bar. And we'll just return 0. So vector fucking free test so that it doesn't get mad at me, and fprintf standard error mod s new line. So it prints bar. If I remove it, it's going to print foo. Okay, so it's just completely overriding here. Message length is VSN printf. String plus vector count of string is just not set capacity. I could just say, look, hpk string temp is string. Then I can set capacity and printf whatever, all of these things to string temp, and then string is temp. Did that change anything at all, or is there another bug in my logic? Just says bar. So vector, oh, because I wanted to set capacity, but really, I really do want to set count. That's the bug in my logic. I set capacity so I didn't have to set count right away, but really I do just want to set count. And then everywhere that we have temp, we go back to being string. Well, that didn't do anything at all. Set count of string to vector count plus message length plus 1. Oh, that's why. Another thing, int 64t count is this. Copy count. That's foo. Where's bar? Bar is still there. Where's bar? Oh, that's, you know, another thing. There's a reason I said set capacity. You want to set capacity and then set count, because of course, don't set count. That's not a good idea. We don't want to include the null term here. Bar. Okay. There's both of our things. We did it. Invalid character in source text and unfinished block comment. Okay, so the other thing we didn't check in here, we did these, but we can say unfinished string literal, boom, and this should be unfinished character literal, boom. Then ASDF should say too many characters, and it's exactly one character, boom. Programming is easy, not a single segmentation fault, all stream. Okay, that is still not, we still haven't gotten to parsing yet. I'm going to add that to the to-do. The viewers probably want to see some parsing, honestly. But we did a whole lot of plumbing work to go make parsing a hell of a lot nicer. I did make everything. I love doing shit like this from scratch. It's not as good a teaching tool, I will admit. Though it is good for teaching you that it's not hard to make things from scratch, I guess. Yeah, compiler completely from scratch, save for the C standard library and like one POSIX extension. I am coding compiler again. This is a different compiler for a different reason. I am trying to write a book. We'll see how it goes. But I'm trying to write a book. And I mean, like, that's empty. This is like, there's some text in it. I'm trying to write a book, and I'm trying to use this simplified version of a compiler, which is still not really simple, let's be honest, as the reference material for writing a book about compilers. This is very work in progress. This is the only thing I have that makes any sense at all, and it's still not great. I kind of started describing the language, but I haven't, like, I don't know, right? I'm working on it, I'm getting my feet wet, figuring out how to write shit. The table of contents looks ugly as hell, but it works. I've stolen the layout of crafting interpreters so I can have a little navigation panel over here. Sure, what do you want to see? So I can click on welcome. That's the first section. It's got a nice little Roman numeral. It shows you all the chapters in the section. Chapters 1 and 2 are the introduction and the Hibiku language. I can click on Hibiku to go straight to it. I can just hit next to go to the introduction, next to go to Hibiku. If I go next, we go to section 2, setting up the project. This section will probably just die because I'm writing a book about compilers, not about building a C project. Maybe I add it later again, I don't know, but I think I'm just going to kill this section. But anyway, it goes, and then we're on section 3, lexical analysis, where I tell you what the fuck lexical means, in case you don't know what that means. And then creating a lexer is part, the first part that I'm actually going to seriously try to write. The rest of this is just, can I bullshit my way into something that looks pretty? This is the first page that I think is going to be important. What the hell is a lexer? How do you make one? Step 1 of a compiler, basically. Am I cutting out multiple times a second now? I don't know. I hope not. Everything looks like, if I'm just talking on my own over here, OBS is reporting a very consistent, accurate volume thing. So hopefully it's not cutting out a bunch. Maybe I can check my not audio properties. Where is filters? Filters. Right, so suppression, gate, then compressor, then gain and limiter. Loud and clear. Cool. Might be just him. Maybe I got a little too far away from the mic and it didn't like it, but okay. I can check it in post and see what's going on. Anyway, so I'm trying to write a book. Never wrote a book before, so this might take a long ass time. It is technically up on my website. I think it's like half up to date. Yeah, that's that, and that's the next doesn't exist. That's fine. This page isn't up to date yet, but I do have it up on my website. I'll start sharing it actually more when it's written. But yeah, so what kind of chapter did you want, Andy? Hi, Andy. I don't think I said hi before. I did. Yeah, I did. I didn't say your name. Unless you don't know what chapter you want to suggest yet, you can always send it to me later. There's a high chance it's already probably going to be in the book. If it's about compilers, there's a good chance it's going to be in there. And I am winding down the stream here. I've been taking CS compiler courses, been curious about compilers and languages over the decade. Lots and lots of books describe ASTs, parsing, lexing, even semantic analysis and stuff. Yep. If it's going to be about backends, I do plan to write about compiling to LLVM, probably C, and ideally making a an x86 64 backend or something like that. Some kind of eventually machine code without going through a high-level intermediate language representation thing. I have never done one in full myself, so I will be learning how to do that properly for writing the chapters. I have a high-level idea, just never done it. I expect to reach the level yeah. Anybody can get here. It just takes time. I've been doing it way too long. What do you use for rendering the book? I recently used Doxify for stuff, and it's really cool. I can show you because I wrote all of that myself, too. I have a little repository, which is available on GitHub, I believe. GitHub.com, Mashiora.com. I built a little static site generator myself in C# at this point, which generates things. I have used a markdown parser library called MarkDig, and MarkDig renders the markdown to HTML for me, and I do some post-processing to it. And then I just, based on the file structure and what I've defined as what sections and what chapters, I generate the table of contents and the file tree for the nav menu, basically. So this gets turned into a tree, generate the table of contents, generate the nav menu, render these off to the actual HTML files here in the final public HTML output, and stick some CSS on it. I've written only a couple hundred lines of CSS to style the whole thing, and I still need to add stuff for the table of contents. Like I said, the table of contents here, ugly. It's using the exact same styling as the chapter pages, which does not work for this tree list thing. FFI, C interop, calling C. Yeah, that is stuff like the C interop stuff I've already done, not extensively, but a lot of in my Laia programming language and other programming languages I've written. So we'll definitely get to FFIs and C interop, no question about it. 100% going to happen. Very easy to do, all things considered. It's kind of the default for anything other than the x86 64 backend. When we get to doing assembly backends, we have to start doing it manually. But if you just generate LLVM or C or something, then you get it for free. So in that sense, it's very easy. Before, by the way, before I was using this C# library to do this, I was just rendering to Pandoc and embedding Pandoc in here, but I wanted to be able to do some post-processing and introspection of the Markdown AST, so I switched to using MarkDig. You could use any Markdown library that supports the features that you want, so that I could introspect the. Let me come down here, just like so. Chapter parser, no builder. I think the tree has it. So I've got really simple stuff in here that's going through the first header in the document, grabbing its inline stuff as a string, and returning it so I can get the title here, for example, right? So I'm doing some very simple AST traversal to get the title of each chapter or section. There's a lot of material on interpreted, but native compiling to both LLVM and even native, yeah. Yeah, we're going to probably tackle LLVM as our first compile target because it's very simple. It's less simple if you're not using it as a library and if your intermediate representation is not similar to it. So I've made a good effort in my Laia compiler to have my IR mirror LLVMs pretty closely so that the translation is nearly one-to-one. But I think for this book, I want to do a register IR that is not a single static assignment. I might go back and do an SSA, I'm not sure yet. SSA is very useful, but for interpreting this, I think the register, non-SSA register IR will be better for interpreting, and we're going to probably write a decently sized interpreter for this language before we get on to compiling. Because I want to do both. There's already crafting interpreters for writing interpreters, I know, but I want to do both. Yeah, Laia, I got tired of streaming Laia because it was very complicated. I was doing a lot of my own, like whenever I was free, I was watching YouTube videos or listening to a podcast or doing it in between work. So the skips in like progress just felt like I didn't want to explain what was going on. I could have just done it, but it just felt weird. I really wanted to have like from like you can see the whole process from A to B. Like I work very little, if any, on Hibiku off stream. I've been working on the static site generator off stream for the same reason I was doing Laia off stream. But I think most of Hibiku can be written on stream, and then that material will get translated into this book. And maybe I write some of the book on stream, so you guys can give me real-time feedback while I'm writing paragraphs of stuff. But yeah, Laia is still in development, still alive and kicking. I can go to run all my Laia tests. We've got all of these tests are passing last I checked. There might be one or two failing because I haven't implemented something, like there's a failure in 4. Something changed and now 4 doesn't work. I can't execute break continue. That's right. I introduced a bug to my for loops that causes infinite loops. So my tests don't actually pass anymore. But for those of you who don't know, Laia is my pet programming language that I really like. That looks like this. Let's pick, this is the one that's breaking things. It looks a lot like C. It's a very C-like language. It's got SSA IR that prints to look like this, and this is how the tests are run. So we compare the output of generating IR to this with Eternal's fcheck plugin, not plugin, fucking whatever. Anyway. And I've also added my own thing that just checks the return code versus the first comment. So I can run execution level tests and IR level tests on the same file. It can also test diagnostics, which is cool. Most of these are very small tests. Favorite keyword, it does absolutely nothing. If you get the joke, you get the joke. Yields from a block. Compound yields from a block. I need bigger tests that are fun. My examples don't exist. One of these has to be a big fancy looking one. This is how C interop works in Laie. We add just a couple of things here to ensure that we don't override the defaults for C. Foreign means by default that there's no name mangling at all. We just get the name of the function, so it'll match up with C, and the calling convention ensures that we are using C's calling convention. And you can tell foreign to use a different name instead, so my wacky function becomes puts, so we can call puts by calling my wacky function. We've got lots of fancy features in there. Is there a channel Discord, by the way? Yeah. In the description of this stream should be a link to join here. I talk a lot in development. A lot of people talk in here. Eternal's in here. He's very smart. You can go show off anything fancy that you've done if you want to go be a show off. Absolutely no shame. Talk about music. Nobody really does that. Linguistics is in there too. I made a language forever ago that I need to finish. I'm going to start talking about the compiler book that I'm writing in here as well. I made a channel for that. Anytime you find something really cool, we can post it to the resources channel here. So like here, programming language I was talking about, how to program C in 4 hours, somebody posted. Bit like that. Lots of fun stuff here. Yeah. So maybe I'll do more Laie streams in the future as well to try to get myself over the finish line of baseline feature set. I have a lot of plans for Laie. Yeah, like I said, I just for some reason, did not enjoy streaming it when it was all scattered stuff. Pointers. Here's my pointer tests. We've got mutable values, which means we have mutable pointer access to test. You can assign to the result of a block. L values can be compound expressions. That kind of stuff already works in Laie and passed all of its tests. It's very fun stuff. We're not going to be going quite so hard in Hibiku with this. We're going to keep the type system relatively simple. There will still be pointers. There might still be references. I don't know. But we're not going to introduce mutability flags, for example. We're probably not going to have 32-bit and 64-bit integers. I'm probably just going to make it a platform with integer for all things. Maybe force it to be 64. I don't know. The book has to end at some point, and the more features I add, the longer it's going to take. So Hibiku will be relatively simple in comparison, though still fully featured as a general purpose language. If I can, and I figure out how to do so, I want Hibiku to support closures. Closures are going to be interesting. By closure... Yes, hello. Give me just a second. Yes, please. Okay. We're making bacon. My favorite easy to understand-ish closure example is we can make an adder for like a of int, which returns function that takes an int and returns an int. And we return function b of int. We could probably infer the return type in this, but we'll just do the whole thing just to be whatever. A plus b. So we return a function that references a value in a different scope. It will close over it, and it will store that for forever. And then we can say add 7 is adder of 7, and then we can print yeah, I don't know how to solve this in anything other than a virtual machine. I've done it in a virtual machine before because I have more control over just how things work, but I've never translated it to... Yeah, efficiently compile, I don't know, but it's very easy to understand. It's very conceptually easy to understand what this closure does. So I could print adder, or add 7 to 5, and that would print 13, 12, 12. Math is hard, turns out. So I want to support fancy features that people love like this, but if it turns out to be too much to do in a compiler book, I don't know. I really want to put it in a compiler book though, because that's like, you're writing a book about compilers, you gotta do that shit. If I need to save time and space on the book, I'll probably cut the interpreter, honestly. Yeah, if I can store it in the closure directly, then that's great, but I'm probably planning to just put it on the heap, if I'm honest. Yeah, exactly. So I'm really tempted to introduce very strong, very invasive type inference, and if we do that, then we can go for the on the stack different sizes thing and have all the closures technically be different types. But I've never done that before. So if I can't get that to work properly, then we'll probably just go the on the heap way. Yeah, anonymous functions or lambdas are very easy. They're exactly the same as regular functions, but closures, yeah. Stack-based closure in a paper. Interesting. I don't fully understand what that means, but like for a stack-based language, or yeah, if it escapes, then you want to do something about it. Yeah, so if we do closures, that's a problem we'll solve. The more things we add that are difficult for the backends to do, the less likely I am to do an interpreter. But I kind of want to do an interpreter. I'm not going to lie. It'd be really cool to add an interpreter to this and be like, it's a compiler book that also interprets. But like I said, crafting interpreters exists. If you want to write an interpreter, you might just want to do that. So we'll see if I write an interpreter. The biggest reason I wanted it to be an interpreter is because I wanted it to be embeddable, have an embeddable, lightweight general purpose language that's also statically typed and can be compiled. That sounds super fun and flexible to put, like, interesting to build in a compiler book to me. But, I guess it doesn't really have to be interpretable. I could compile to machine code in memory if I wanted it to be interpretable, for example. I could do a JIT compiler. I've never built a JIT compiler either, so we'll see where we go. By the time we get done with semantic analysis, I'll probably have a better idea of the scope that we're going for. It shouldn't take us long to get there either. I'm imagining a couple streams on parsing. Parsing this language is going to be much easier than parsing Laie, for example. Laie, I'm very stubborn and I made a hard to parse language. Yeah, if we do the interpreter, that's another thing I want to figure out. If we can get it to the point where we've got a robust dependency system that can basically JIT compile code to at least the interpreter language, then we could have it be its own metaprogramming language as well. That would be a fun feature to make it feel real. You can compile it to native code. You should be able to compile it to some bytecode instead of, yeah. Yeah, that's my first step was going to be we're going to do a bytecode evaluator, which is why I wanted to do the register IR instead of an SSA. So we can do a primitive register allocation on an infinite register machine. I'd have mutable registers. And then we can do a VM using that. So then, yeah, if we have the dependency system set up properly to compile things down to an interpretable format like that in the middle of SEMA, then we get compile time execution for free. I'm planning to JIT compile code that needs to be evaluated at compile time. Yeah, that's probably what I'll do for Laie when I get there. I was going to do something similar like this, but I think it'll just be better to JIT compile. In the long run, at least. Short run, I'm going to hate figuring that shit out, but it should be possible. Should be possible. All right, my throat is starting to hurt. I don't usually talk for long periods of time. I enjoy chatting. We'll probably get to chat more as my voice gets used to it, but I am going to go chill with my roommates and call it here. Next stream, we should be parsing things, because that's really all that's left on the list is parse. Unless somebody really wants to see me do the diagnostic renderer sooner than I want to do this, but I gotta figure it out. We're gonna do parsing next time, maybe look at the book a little bit, but I'm gonna go relax. It's been fun. Thanks for joining me. Join the Discord. if you haven't already. I think everybody here has already probably fucking done it. And you can view the source code for Hibiku on my GitHub. Should also be in the description. I'm probably not accepting pull requests because I'm trying to build this from scratch for the purposes of writing the book and all that. But yeah, goodbye. Ta-da. See you later. Have the good fun.